In the diagram below, ST and U are vertices of triangle STU. P is the midpoint of SU, and Q is the midpoint of TU. UD is perpendicular to ST, and angle S is equal to angle T. Part A, determine the coordinates of S and T. B, determine the gradient of UD. C, show that 2PQ is equal to ST. D, prove that PQ is perpendicular to ST. E, determine the coordinates of D. And F, calculate the area of triangle STU. Let's start with part A, determine the coordinates of S and T. Now, from the question and the diagram, we can see that P is the midpoint of SU and Q is the midpoint of TU. And we can use the midpoint formula to find the values of S and T. Let's start with point S. We know that P has coordinates -3, 4. So let's make a note of this. It is the midpoint between point S and point U. We need to find the coordinates of S, but we know the coordinates of U are -1, -1. We can make a note of this as well. When we are given the midpoint and we need to find another point, we can use the midpoint formula, but it is a good idea to find the X and Y coordinates independently. Let's start with the X coordinate of point S. From the formula, we know the X coordinate of the midpoint P, let's call it PX, is equal to the X coordinate of point S, say SX, plus the X coordinate of U, let's call it UX, over 2. The X coordinate of P is -3, so we say -3 is equal to the X coordinate of S, which we need to find, so we can call it SX, plus the X coordinate of U, -1, let's put this into a bracket, all over 2. And now we can solve for SX. Let's multiply both sides by 2, and we get -6 is equal to SX minus 1. Now we can add 1 to both sides, and we get -5 is equal to SX. This is the X coordinate of point S. Now let's find the Y coordinate. So we can say the Y coordinate of midpoint P, let's say PY, is equal to the Y coordinate of point S, SY, plus the Y coordinate of point U, UY, all over 2. The Y coordinate of P is 4, so we say 4, is equal to the Y coordinate of S, which we're trying to find, plus the Y coordinate of U, -1. Let's put -1 into a bracket, all over 2. Now, to solve for SY, let's multiply both sides by 2. 4 multiplied by 2 gives us 8, which is equal to SY minus 1. Let's add 1 to both sides. We get 9 is equal to SY. Now, S is an X coordinate of -5 and a Y coordinate of 9. We can write down the coordinates of S as -5, 9. Let's make a note of these coordinates on the diagram as well. Now we can make some space and look at the coordinates for point T. From the question and the diagram, we can see that Q has the coordinates 4, 1. So let's make a note of this. It is the midpoint between point T, which we need to find, and point U, which still has coordinates of -1, -1. Again, we have the midpoint and one given point, and we can use this to find the coordinates of T. Let's start with the X coordinate. Let's say the midpoint, Q, X coordinate, is equal to the x-coordinate of point T plus the x-coordinate of point U all over 2. The x-coordinate of Q is 4, so we say 4 is equal to the x-coordinate of T, call it Tx, plus the x-coordinate of U, -1, so say -1 in a bracket, all over 2. Now we can solve for Tx. Let's multiply both sides by 2, and we get 8 is equal to Tx minus 1. Let's add 1 to both sides, and we see that 9 is equal to the x-coordinate of T. Now that we have the x-coordinate, let's find the y-coordinate. We say the y-coordinate of the midpoint Q, let's say QY, is equal to the y-coordinate of point T, let's call it TY, plus the y-coordinate of U, UY, all over 2. The y-coordinate of point Q is 1, so we say 1 is equal to TY, the coordinate we're trying to find, plus the y-coordinate of U, -1, let's put this into a bracket, all over 2. Now we can multiply both sides by 2. We get 2 is equal to TY minus 1. Let's add 1 to both sides, and we get 3 is equal to TY. From this, we know that T has an x-coordinate of 9 and a y-coordinate of 3. So we can write the coordinates as 9, 3. Let's make a note of the coordinates for T on our diagram as well. And now we can move on to part B. Determine the gradient of UD. Now, we don't have the coordinates for point D, and without these, we cannot use the gradient formula. But the question tells us that UD is perpendicular to ST, and we can see it in this angle on our diagram as well. Now, in this case, we do not need to prove the lines are perpendicular. This has already been given to us. We need to use this idea to find the actual gradient. We know that if two lines are perpendicular, their gradients will be the negative reciprocal values of each other. So if we can't find the gradient of UD, let's find the gradient of the perpendicular line ST.